All right, so welcome class. Let's burn through this quickly before I go learn about marriage. We started this with these symbols, and I think you're pretty clear what these mean now that you've done a couple reactions. But if not, the arrow means yields, or basically a reaction going from reactants to products. That's what you put in between. If we have an S in parentheses, that means that we're dealing with a solid chemical. An L is a liquid, G is a gas. AQ means that it's aqueous or dissolved in water, and we did some stuff earlier on with salt would be dissolved in water, or we used vinegar, which was not concentrated, so it was aqueous. Acetic acid, which was dissolved in water. The little triangle means heat. If there's an arrow both ways, that means the reaction can go both ways. It's a reversible reaction. Equilibrium might be used for that. Plus means and. Hopefully that doesn't shock anyone. And the coefficient, that's the mole ratio. And it's a whole number used to balance equations. And that's what we've been manipulating. So solid calcium carbonate reacts with a solution of sodium nitrate to form. Oh, yeah, well, we're not doing that. Let's move on. Balance. So an equation is balanced when the amount of each element of the reactant side is equal to the amount of each element on the product side. And we did the FET. Remember, it's not the number of molecules, it's the number of atoms. So your oxygen has to be balanced on both sides, but it's possible to have different numbered molecules on each side, but the number of atoms do have to be equal. And we do balance equations to satisfy the law of conservation of mass. So here you can see that there are, this is probably H2 and O2. Nope, not going to be that. Maybe ammonia. So maybe N2 and H2. How about that? So you can see here that the number of molecules on this side, 1, 2, 3, 4, 5, 6, 7, 8. And on this side, it's only 4. So the molecules aren't equal, but the number of atoms, the number of hydrogens, the little circles here, are the same on both sides. And the number of nitrogens are the same on both sides. And that's what balanced reactions are. And law of conservation of mass, so if we took a calcium chloride solution and a sodium sulfate solution, and we kind of poured the calcium chloride solution into the sodium sulfate solution and still weighed what happened afterward, there would be a precipitate, a solid that formed, but the mass before and after would not change. And that's what we're doing. So rules for balancing equations, write the formula of the reactants and products, take inventory of all the things, balance. Yeah, don't change subscripts. That's basically a big key here. And make sure that the coefficients are the lowest possible ratio. So I don't know. I didn't grab a pen, but let's try it with my finger, shall we? All right, or maybe not. All right, so here you have 2 aluminums and they came from here. So that's usually where I start, is that you would need a 2 here. And then you have 3 oxygens and they came from here. But notice the oxygens are coming in pairs. So you can't put a 3 here. So you have to sort of think of the lowest common factor that has 3 and 2 in it, and that would be 6. So if we had 2 here, look at that, folks. That would give us 6 oxygens, and then we can put a 3 here, and that would give us 6 oxygens. So on the oxygen side, we have 6 on this side, and we have 6 on this side. I'll spare you doing this much. And then aluminum-wise, aluminum, this is not the quality of Khan Academy. All right, so 2 times 2 is 4, right? There's 2 aluminums per formula unit of aluminum oxide. We have 2 of them, so that means there's a total of 4 aluminums. So on each side, we have 4. And if you want more of this, you can look through. I did some videos already on balancing, but there's some good chicken scratch for you. I'm going to avoid this next one, but notice both of these are synthesis reactions. You have one product, and we'll talk about that in a minute. For these, this here is a double displacement. Sodium is coming with sulfate and leaving with a hydroxide. Aluminum's coming with hydroxide and leaving with sulfate. I usually use one of these bigger ones that has a bunch and then start balancing there. So this has 3 sulfates. This has 3 of these sulfates. So that means we're going to need a 3 here. And that 3 will satisfy the sulfate. But the sodium now is a total of 6 because we have 2 per formula unit. We have 3 formula units, so there's a total of 6. So that means there's going to need to be a 6 here. And if we have 6 hydroxides here, they came from here, each one gave us 3. We're going to need a 2, and then 2 is going to help us with that aluminum. So that's another example of how to do that. This is a combustion reaction, which we'll talk about in a second. So here they are, the classifying chemical reactions. So if you have one product, like we did before with these two things, right? You have one product, there's aluminum oxide or water, if you ignore the chicken scratch. That will be a synthesis reaction. So things are coming together, in this case copper and sulfur, to make copper 1 sulfide. The copper 1 means the charge is +1. +1. Look at me concatting me, that one. And you need 2 +1s to equal the -2 of the sulfur. But bottom line is that's a synthesis reaction because you have one product. Moving on, if you have one reactant, so one compound breaking up into multiple compounds, that's called a decomposition reaction. And if we have single replacement, something that's by itself sort of takes over one of the two things in the compound and kicks one of the two things in the compound out to be by itself. So there are two examples of this. There's cationic replacement, which is when the metal or the positive aspect of a compound gets kicked out. And an example here is zinc is a metal. It's going to kick out the positive H, which is an acid. And as a result, kick that H out to be by itself as a diatomic molecule, H2. And zinc will be replaced in that compound. And anionic is when the anion or the negative aspect. We only do this with halogens. You don't need to know this for the test Friday, but if you have some halogen which are all diatomic, so NEX2, F2, Cl2, Br2, I2, reacts with some compound that has a halogen in it, it's going to replace it. So CO2 replaces the Br here. So that's single replacement in an anionic form. Double replacement is when you have two couples coming in and they leave with different people they came in with. And again, I use Mario for that one. All right, by the way, when I took a course online like this, my teacher would always take a drink like this. So I just thought I'd annoy you like that because he used to do that all the time. All right. So a double replacement reaction is when you have two things, two compounds going in, two compounds leaving, and they switch partners. And then the last one is a combustion reaction. So you start with some CH combination, C2H6 or C3H8 or whatever it is. You add oxygen. And the key here really is if you have carbon dioxide and water as your products, then you've had a combustion reaction. There's only two products, and just think of things in the world. Carbon dioxide and water are everywhere, and the reason they're everywhere is because they're very stable, and that there's a lot of combustion reactions that are causing that. So, and that is that. And then the last thing we did was that leading acids have a leading H. And when you have a leading H, it's going to act like the cation or the metal. So HCl is hydrochloric acid. This leading H means it's an acid, and that means that H is going to sort of be a plus charge. H2SO4 is sulfuric. HC2H3O2 is acetic acid. So I think that's all we did. You don't need to know these yet because I've decided you're not going to need to know naming for the quiz thing Friday. So that is that. I hope it helps. I'm going to go learn about marriage.